So now let's come to the implementation part. So this is the file where we are using both OpenCV and OpenCV super resolution module to perform image upscaling using super resolution techniques. So we have written the code. Let me explain you the code. So the import libraries we have used is CV2, matplotlib.pyplot as PLT. So what does CV2 does that it's a popular computer vision library that is used for various image processing tasks, and matplotlib is used for displaying images and creating plots. So where do we read the image? This part. So the code reads an image from the file that is the AI courses by OpenCV-github.png using OpenCV's cv2.imread function that stores it in the image variable. And how do we display the original image? So what we use is the code uses matplotlib to display the original image by converting the BGR image to RGB format using this parameter, that is the image with parameters colon minus 1, and then showing it in plt.show, that is here. So then how do we crop the image? So the code crops the image to retain only the top 80 pixels and the right 850 pixels. The cropped image is then stored in the image variable, and then after cropping the image we come to the super resolution setup that is associated with the instance that is present in DNN super resolution implementation underscore create. So this is used for the resolution module and assigns it to the variable SR. After the resolution setup we do load super resolution model. So a super resolution model is loaded from the file that is dev.jpg, and this is done using the sr.read model function. This model is used for the upscaling process. So after this we set the super resolution model. Here what we do that we set the super resolution model to EDSR with a scale factor of 4 using sr.setModel with a EDSR of 4. Then how do we upscale the image? We use sr.upsample function that is used to upscale the previously cropped image, that is img this image means this variable. So this is done using the loaded super resolution model, and the result is stored in the result variable after upscaling it. So then how does OpenCV upscale? The code performs a standard upscaling of the cropped image, that is img, using cv2.resize method. So what it does is it scales the image up to a factor of 4 and stores the result in the resized variable. So now how can we display the images? So the images are displayed in the matplotlib to create a figure using 3 subplots. So what does the first subplot do? It displays the originally cropped image. The second subplot, what it does, it displays the image upscaled using the super resolution model, that is in the result variable. The third subplot displays the image upscaled using the OpenCV's resizing function in the resized variable. So here we have used subplot 3 times. So it is the first subplot, this one is the second subplot, this one is the third subplot. The parameters used for first subplot is 131. The parameters used for second subplot is 132. The parameters used for third subplot is 133. So now let me give you a short summary of this convolution file. So this code allows you to visually compare the original image, the super resolution upscaled image, the OpenCV upscaled image. Super resolution techniques aim to enhance the details in images, especially upscaling by a significant factor, and it demonstrates how to use OpenCV's super resolution model for this purpose.